A book that has a mass of 2 kilograms is pushed across the table by a force of 10 newtons, but it is at a constant velocity. Friction is present. Also, it tells me that 1 kilogram is the same thing as 9.8 newtons. So actually, this is a book, and the only thing that I know about it is that it is 2 kilograms. But they told me something about kilograms. 2 kilograms. I need to turn that into newtons. And so the ratio says that 1 kilogram is the same thing as 9.8 newtons. If I do the math, that's 2 times 9.8 divided by 1. And so I get 18.6 newtons. Let me make sure. 9.8 times, 19.6 newtons. And so now I can add that to my free body diagram. The force due to gravity here equals negative 19.6 newtons, but then the table is also supplying, force table is supplying 19.6 newtons. And so, the force net equals all the forces in that direction plus all the forces in that direction. So that's 19.6 plus a negative 19.6. So I get 0 newtons. But then the question goes on to point out that there's a force in this direction, force, push, of 10 newtons. But it says it's traveling at a constant velocity, and that means it must be in equilibrium. That tells me that the force in this direction must also be 10 newtons. So force of friction equals 10 newtons. Actually, negative 10 newtons, right? Because it's in the opposite direction. And so, when I figure out the force net in the left-right, or the horizontal axis, that's all the forces in this direction plus all the forces in that direction. So that's 10 newtons plus a negative 10 gives you 0 newtons, and it is in equilibrium.